Hi, I'm Senator Malcolm Roberts, and I'm in Brisbane, Australia, and I'm interviewing Professor Ian Plimer, one of the world's most famous geologists and most competent geologists and climate scientist. I'll just go through his qualifications. He's an Australian geologist, Professor Emeritus of Earth Sciences at the University of Melbourne, previously a Professor of Mining Geology at the University of Adelaide. Actually, also, Professor Plimer, you were also at the University of Newcastle, weren't you?
I was at University of Newcastle, professor there, professor at University of Melbourne, and professor at the Ludwig Maximilians Universität in München, Germany.
What about a few specifics? Ocean alkalinity, as I understand it. And notice that they call it, you know this, they call it ocean acidification, making the oceans acid. They're not actually acid, they're alkaline, that's for a start. And as I understand it, the oceans bob around about 8.3 on the pH scale. They're alkaline clearly, and they're just varying naturally, that alkalinity, just like everything else in nature varying naturally.
Well, pH is a log scale. So if you want to change pH by 1 unit, you need a lot of acid. The second thing is, you're quite right, there is huge variation in oceanic pH. Humans have controlled oceanic pH in very small areas. For example, at offshore sewage outlets and places like this, you do get a pH change. You get a slight pH change where you're getting exhalation of carbon dioxide and acids from submarine volcanoes into oceanic waters. But the ocean is a dynamic system, and the oceans have been alkaline since the beginning of time because we have a buffer in the oceans. And as we have rainwater hit the land, dissolve materials and wash those materials into slightly saline waters into the oceans, calcium is a buffer. And the more calcium we have in the oceans, then the more carbon dioxide dissolved in the water as carbon dioxide, bicarbonate or carbonate, it will then precipitate as limestone. So we can actually control the ocean pH by calcium. We can also control it by boron. And the third buffer we have controlling it is that seawater circulates, and it circulates through ocean floor sediments, and it circulates through ocean floor rocks. And they have minerals in them which react. And those reactions keep the oceans alkaline. We can duplicate those reactions in the laboratory. We can see the end product of those reactions when we've pushed a bit of the ocean floor up onto the land, as we see in Papua New Guinea or Cyprus or many parts of the world. And we can measure it by deep ocean drilling programs. So we're pretty confident from many lines of evidence that you cannot have an alkaline ocean. And the only way you can have an alkaline ocean...
So you can't have an acidic...
Well, you cannot have an acid ocean. Yeah. And the only way we can have an acid ocean if we stop the planet doing what the planet does, and that is be dynamic. And as soon as we stop volcanicity, as soon as we stop sediments coming into the ocean, then it will take a long, long time before we change the pH of the oceans, and we'll be a brown dwarf before that happens.
Okay. What about sea levels?
Well, sea level's been up and down like a yo-yo, and sea level rises and falls. It has in measurable historical times. I've been to the ancient Roman city of Ephesus. It was a port city. It's 15 kilometres inland and I think about 12 metres above sea level. Mentioned in the Bible. Why is that? Well, it's because the land level's risen. I've been to the ancient city of Lydia. I've been down the main street in a yacht because Lydia has sunk. And that they're both in Western Anatolia. So just in one small part of the world, the land's gone up and down. In Australia and New Zealand, we've had a rifting to give us the Tasman Sea. And Western New Zealand's gone up, Eastern Australia's gone up in the Great Divide. So we are having regular earthquakes as a result of the land still rising. We can see in Eastern Australia, we can see all these rock platforms. And those rock platforms are from where the sea was a couple of metres higher in the Holocene maximum about 5,000 years ago. Sea level since dropped. We can go to Scandinavia and see that because Scandinavia had 5 kilometres of ice on it, the ice is now gone, Scandinavia's risen. And we can see all the old beach lines going to 340 metres above sea level. We can see old lines of shells where these shells were at sea level, and now they're a couple of metres above sea level. Bob Carter did some wonderful work on these up in North Queensland, and we can see that either the sea level's fallen or the land level's risen. We can see there's micro atolls which are dead, which are exposed. So either the sea level has fallen or the land level's risen. So you cannot talk about sea level unless you talk about the concurrent land level rises. Now, people say, oh, that's just geology. Sorry, land level rises are very fast. Go to the port of Ephesus, go to Lydia, go and look at any coastal areas. So we have had sea level changes since the last glaciation, where we've had a rise of 130 metres, but it's been a rise and a fall and a rise and a fall and a rise and a fall all the way up. We're now getting a slight decrease in sea level since the Holocene maximum. And we've seen in past ice ages, such as the ones I mentioned, the Sturtian at 650 million years ago and the Maranoan at 630 million years ago, this is where we had sea level changes of 1,500 metres. If you load up the ocean with another 1,500 metres of water, the oceanic crust is flexible. It actually sinks a little bit. So you're getting sea level rises and falls for the same reason. So sea level rise and fall, as Niels Axel Murner, the chap you mentioned earlier, has shown, are very, very complicated. You can get a land level fall if you extract oil or water from the sediments. You can get a land level fall by building a city and having vibration from traffic. So a sea level rise or fall is not related to climate. That's one of the processes, a sea level rise and fall, but it's not the only process. We get a sea level rise near the Andes because the gravitational pull of the Andes has pulled the sea up towards the Andes. We get a sea level fall where you have a weather high over the oceans, and a sea level rise where you get a weather low. We get huge changes in mean sea level due to weather. So to simplify the process of sea level is to be naive, and again, like carbon dioxide, to claim that sea level is due just to one factor, or to claim that climate is due to one factor, is ignorant, because people are not aware of all the other processes that go on. It is the petroleum geologists and the coal geologists who use sea level changes as a major exploration technique. And we can see different types of coal, depending upon whether you're in the back lagoon or whether you're in a lagoon area where you might have a lot of pollen and spore, whether you're on the delta plain or the upper delta plain. These coals are different coals. These are coking and steaming coals. You can actually look at the ancient environment from looking at the coals. The petroleum geologists look at the same. They look at what sea level does to be able to work out what's happening in a basin, to be able to work out where certain sediments are being deposited. So we use sea levels in a practical sense, and Exxon had a sea level geologist, Vail, who constructed the Vail curves. They are used by academia and by petroleum exploration to look at petroleum basins. So we've used sea level for 50 years. We know it's been changing a lot, and we've used it for practical purposes. It's not been used by real scientists for political purposes.
Great Barrier Reef. We visited the Great Barrier Reef, Senator Hanson and I, in 2016, and we had Alison Jones, I think, was the coral scientist there, and she said that the southern Barrier Reef was formed about 6,000 years ago, Professor Plimer, and the northern Barrier Reef was formed in its current location about 8,000 years ago. We know that sea levels changed around 120 metres not so long ago. So the Barrier Reef moving. That's correct, isn't it?
Yes, the Barrier Reef, you used the words not so long ago. That's absolutely vital to say that, because the Barrier Reef isn't permanent. We've lost it, we've gained it. In cold times when sea levels dropped, the inner reef has died. The reef's migrated northwards. We have some Aboriginal legends, and a chap in Cairns has written a book on this where you can actually, he's spoken to Aboriginal populations where they've got myths about people having to go way out on the coastal plain to go fishing. That's telling us that the sea level was much lower. So sea level's up and down. The Barrier Reef has come and gone many, many times. We've got a 3,500-year record of reefs on planet Earth. You can go to places in the Kimberley of Western Australia, a place called Fossil Downs. You can stand on a hill and you look as far as the eye can see of a Great Barrier Reef with coral in it. You can go inland from Cairns and the Great Barrier Reef to Chillagoe. And surrounding Chillagoe are these hills of limestone. In the limestone are caves where you've got unique flora and fauna. You've got remnant wet tropical flora and fauna there, telling us climate has changed. The limestones, they're old coral reefs. Sit in the bar at the top pub, not the bottom pub at Chillagoe, the top pub, the Post Office Hotel, and before you look at your drink, just look at the bar. It's made out of a coral-rich limestone from the hills just behind the bar. And this is telling us we've had reefs. Reefs come and go. Coral has been with us for about 500 million years, modern corals for less, but the appearance and disappearance of the Great Barrier Reef is normal. And we have biological competition, and there is warfare taking place on the Great Barrier Reef. And sometimes one critter will get the upper hand in a small part of the reef, like the crown of thorns. Other times there will be genocide going on and the crown of thorns will die. This is normal for any ecosystem where you've got warfare going on. The Great Barrier Reef is dynamic. It's one of the great reefs. It's a cool water reef. We have much warmer reefs up in Thailand and Papua New Guinea and the Red Sea. It is an absolutely beautiful natural phenomenon, but it's just part of the rich tapestry of the history of life. Reefs come, reefs go.
Yes, and the Barrier Reef right now is in fine health, but they make out when we have a bleaching event, which again is entirely natural. And did you catch the news in 2008 that in Queensland we had record cold temperatures in the winter of 2008? It was June, and the southern portions of the Barrier Reef bleached. But we didn't hear that from the ABC.
I'm not surprised. Not surprised. Two things. Reefs are dynamic, and we know that reefs die due to cooling and sea level drop. Rarely reefs will die from predation. Rarely they'll die from inundation by sedimentation, and rarely they'll die from storm activity. But normally it's from being exposed. And once they're exposed, they die because they're a marine phenomenon.
Yeah, and that's what we've seen up in northern parts of the reef where there has been some bleaching in recent years. We've seen the sea level drop, the reef exposed. We've seen no wind for several days, so it became hot. And we've also seen at the other extreme bleaching during cooling events. So we only hear one side of the story. And they don't tell us either, Professor Plimer, that on any one day, the temperature in the northern part of the reef is 4 to 5 degrees warmer than the temperature in the southern portion of the reef. And they don't tell us that the temperatures in Thailand on their reefs are 2 degrees higher than the Barrier Reef and contain some of the same species of coral.
And the Red Sea, which is even warmer, and they've got an inner and outer reef at the Red Sea. I've been fishing on the inner reef. It's at 28 metres depth. Same sort of species. Same species.
Let's. What about dry periods? We've just been through a drought, and it's still going on. It's not over yet for some people. Dry periods. Professor Tim Flannery, who's a climate communicator, wrote. He must have a poor memory because he was talking about the endless drought. It'll never rain again, and all this kind of nonsense. But in an Australian Geographic article that was released just a few years ago, while he was in the thick of things telling us about the dryness here, he said in writing, I've seen it, that 20,000 years ago, the climate around Melbourne was far, far drier than today. I mean, how do people get away with this rubbish? I mean,
well, we have had long periods of drought in historical times. These have wiped out some of the great empires in the Middle East, where we've had salinity, lack of water, and inundation by sand dunes. on the geological record, we see that we've had very long periods of drought, and they've given us red sandstones, like the old red sandstone of the UK. And we normally get these long, big periods of drought with salt deposits when it's cold, when there's very little water vapour dissolved in the atmosphere. So drought is a normal phenomenon on planet Earth. Drought is exacerbated by cold times, and in droughts in Australia, we can actually see the last glaciation. So in Australia, we had little vegetation in the last glaciation. We had massive anticyclonic winds bringing sand dunes around, and you can see the pattern of sand dunes around Australia, and we can see what were salt lakes that have been dried up. And then we've seen warmer times and wetter times where these lakes have had water in them, and we've got parts of inland Australia where we've still got tropical vegetation which are sitting in the deserts of Australia. There's a place called Hidden Valley up in the far, far north Flinders Ranges up near the Strzelecki Tract, where we've got tropical vegetation. We've got tropical vegetation in Kings Canyon in the Northern Territory. So we have the vegetation telling us climate has changed. We've got the sand dunes telling us this. We've got the sand dunes telling us that we've had long, long periods when it was dry and it was windy and the vegetation just died out. So drought is normal.
Right. Let's have a look at some of the substitutes for science, what is known as pseudoscience. Politicians and journalists, and sadly many academics, use these alternatives to science or substitutes of science instead of science. First of all, claims of consensus. Is that science?
No consensus in science. That's not a word of science, it's a word of politics.
Right. The use of emotion, particularly fear of catastrophic consequences, guilt and pity. Science?
Science is lacking any emotion at all. It's tied into data and tied into skepticism. And guilt may well be a hangover from past cultures. Emotion, it probably shows you've had a very sheltered life. Science doesn't deal with emotion. It doesn't deal with guilt. It deals with data.
The use of if statements, and it's very cleverly done. Professor Will Steffen, the chemist, is remarkable at doing this. If Antarctica melted, sea levels would rise 20 metres. If the temperature went up 20 degrees, we'd all die. This kind of stuff. The key is in the if and then what follows. Complete rubbish. It would never happen. So the if statement, is that a substitute for science?
No, not at all. But it provides fodder for the sensationalist media. And media is suffering badly. More and more people are going away from the print media, going away from free-to-air television. And so they have to be shriller and more sensationalist to be able to get the audience they want. And so those ifs just feed the media.
What about the use of, well, you've already told us how peer review these days is now buddy review, it's pal review, it's not really a review at all. What about the use of celebrities, actors and socially awkward 16 and 17-year-old girls?
Well, these celebrities have to do 3 or 4 takes of a simple sentence. And to me, that doesn't indicate that their cranial wiring is as good as it could be. So I think for a celebrity to make some extraordinary scientific claims, you can demolish it very easily. So if you get a celebrity talking about carbon pollution, just say, well, you're talking about carbon dioxide. What's the molecular weight of carbon dioxide? And they won't be able to answer it. And immediately it shows people what they really are. They're drongos.
Yeah, but they haven't got a clue that carbon dioxide is a gas and a colourless, odourless, tasteless gas essential for life. And carbon can be a black graphite. It can be a colourless diamond.
Yeah.
Hardest known natural.
There are 8 allotropes of carbon. Only one, a very, very rare one called diamond, can be colourless, but not always. And to use a poor, ill 16-year-old as your Joan of Arc, I mean, really, that's the ultimate of child exploitation. That is child abuse.
What about computer models, particularly computer models that are unvalidated, which is what the climate models are? They're unvalidated. They've already been proven wrong. They're not based on an understanding of the climate factors they're supposed to be modelling. So a computer model's science.
No, they're not science. A computer model is a naive attempt to try to understand nature, and you don't promote it as a prediction of the future. And that's what's happening. It is not science. It is not data. It's a process of massaging data to simplify it, to try to understand how nature works.
And you know that in your line of business, you have to put forward a result that withstands scrutiny, and you could be locked up if you make a prospectus or a financial document that misleads. Yet these people, they can't call their projections predictions and forecasts because they're unvalidated, and yet they're called projections and given the sanctity of as if they're true.
Yes, well, if you made a projection in the mining business on production, metal prices, share price or whatever, you'd go to jail for it. There is a responsibility.
Yeah.
Now, that responsibility seems to have passed the climate industry by, and it is an industry.
Yes. What about the use of smears or ridicule, whether deliberate or direct or indirect? Things like labels like denier, skeptic, conspiracy theorist.
This shows that people cannot mount an argument based on knowledge. And the best way to do it is to cancel you, to denigrate you, and then they have won the argument. I'm sorry, we've had 2,500 years of dealing with logic, and that shows that these people are ignorant, that they are political activists, and that they do not have the knowledge to sustain their position.
A common one that comes up when we challenge things is, oh, do you believe in the moon landing? And you know, they ask the question so they can't be accused of defaming, but there's a subtle implicit, you don't believe in the moon landing. So they're just completely destroying people, trying to destroy people, and the media fall for it.
Well, they've used the word believe, and that's a word of religion and politics. It's not a word of science. So there is, I think, enough validated data around to make me very comfortable and very comfortable that we've landed on the moon, collected moon rocks. I've seen the data on moon rocks. I've handled moon rocks. I know that they are slightly different from terrestrial rocks, and I'm excited that we have, in our lifetime, been able to sit in our lounge room and watch exploration of the moon. And we can do the same with Mars, and I think that's fabulous.
But it gets very worrying when someone like, what's his name, Brian Cox, who's now trying to become a celebrity like David Attenborough, who claims to have a science background, then invokes questions about the moon landing. Do you believe, Senator Roberts, in the moon landing? You know, this kind of stuff. I mean, when a supposedly serious scientist uses that kind of tactic, he's not a scientist in my book. When the BBC starts spreading his nonsense and the ABC spreads his nonsense, that brings into question serious problems with government and government broadcasting.
Well, he's using a political word. He's not using the word of science. And he immediately, the word believe is used, he's pushed a political barrow, and that's where you nail them. So,
and what I do increasingly is, as you just suggested, the moment one of these substitutes for science comes up, I just say, well, thank you very much for accusing me of that or saying this, because using consensus or a model, because it indicates you don't understand science and you haven't got the data and the logic to counter my argument.
Yeah, exactly right. That's the only way to do it.
History shows that science is vital for understanding the natural world. It's given us much more material development, human progress, safety against nature's power and vagaries, against famines, against drought, flooding, storms, famines, bacteria, viruses, diseases. Isn't science absolutely essential to protecting humans and human life and ensuring human happiness?
Yes, of course. We don't go out and do a rain dance. We try to understand what's happening. We don't face west and throw a few stones in the hope that we will not have crop failure. We don't sacrifice people just before we harvest our maize. That was long ago when we didn't understand how the planet works. We have a better understanding of it now. And as a result, we keep having an increase in productivity of food. We keep having an increase in the quality and standard of living. And this is all due to science, which is then put into practice using engineering.
And so science is arguably even more important to us, Professor Plimer, because science gave us freedom to think, freedom to speak, freedom to exchange, freedom to travel, freedom to discover things. Up until the use of science, people were ruled by those who were the bullies physically, the bullies financially, the bullies in terms of religion and trying to scare people into believing certain things would come to them, people who intimidated socially. These were the people that ruled. Now with science, we've got a much fairer system, a much freer system, and we've got that progress, which I think is science's crowning glory. Freedom.
Yes, I think science has released us from many things. It's released us from serfdom. It's released us in many ways from despots. It's given us the ability to pose the great questions and explore them a little bit. And we still have the great questions, but it enables us to exercise our brain much more than we could 500 years ago.
But instead of responding to a threat, I just turn to someone and say, well, where's your argument? And then I go with the argument.
Yeah, show me the evidence.
With the data.
Very simple. Happy to do it, but show me the evidence, please.
So who pays for the abandonment of science and the distortion of science?
Oh, well, the community will pay terribly, but they won't know they're paying until we're well down that path of destruction. And you've only got to reverse what we've seen in the past and go back to what it was like 500 years ago. It would not have been very pleasant living in the Little Ice Age, being ignorant, being ruled by despots, having power out of your hands, having no vote. And this is why you've got a name like Johnson. You know, you were the son of John. You do exactly what your father did. He might have been a carpenter, and his father was a carpenter, and his father was a carpenter. We have now the freedoms to be able to break away from that. Now, we'll go back into that system in years to come if we don't continue to advance knowledge.
So Maurice Strong, who started this global warming rubbish with the UN, and he's the grandfather of global warming, the creator of global warming, the fabricator of global warming. Maurice Strong was about control, and he was very effective in terms of networking and setting up systems to drive control. So really what he's done is he's undermined the freedom, he's undermined the human progress, and and he's now trying to use it. Well, he's dead now, but his legacy is trying to use the UN, trying to use it to control people, whether it's property rights, whether it's energy, whether it's water. These are fundamental to our way of life. They're now trying to control us and how we live, our regulations about what is supposedly sustainable. So these are all about control as I see it. And Maurice Strong made that point himself. There's nothing new in what I'm saying. He made it himself to control people.
Well, I see the environmental movement, the green movement, has got nothing to do with the environment. It is unelected people who want to control you and want to control your wallet, the way you think, where you travel, how you work, how you live. It's all about power. It's got nothing to do with science or the environment.
And what we see is that science has been fundamental to human progress. I mean, who 200 years ago could have envisaged what we have today? Just 200 years ago. Who 200 years ago? There wouldn't have been a king who lived as well as people on welfare live today.
No, exactly.
Lifespan, health, security, safety. Unbelievable.
We're living in the best times ever to be a human on planet Earth. We are well fed, we're housed, we're living in warmer times than 500 years ago. We are so fortunate, something we take for granted.
And there are still people who are living in poverty right around the world, but their percentage of the human race that's living in poverty now is far, far lower than it's ever been, and it continues to decline thanks to science. And so people who are destroying science are now destroying human progress. They're destroying the elevation of people out of poverty. Look at China in terms of at least their reliance on science, while their lack of democracy is a severe impediment. At least their use of the science to improve their material welfare has done enormous benefit to Chinese peasants.
Well, hence, Senator, the name of my next book, which comes out in November 2020, and the book is called Green Murder. Green policies kill people. They kill wildlife, they kill forests, and it is about time we realise that this is nothing to do with science, nothing to do with the environment. It's about power, and that power destroys.
It's about control. And I noticed that you used the term a little while ago about orchestra, the symphony of life on the planet, such beautiful, evocative terms. We live in a universe, which, as I understand it, is a translation from uni meaning one, diverse being song. We live in one song. That's the whole universe. There are many things going on. The trumpets are playing over here, the violins are playing over there, the guitars are playing. It's all going on. And yet we seem to be falling out of the capture of science. We're going back into totalitarianism.
Well, just to use your orchestral analogy a little bit further.
Well, it was yours, actually.
One of the hallmarks of Western civilization has been music, which has come out of the church. And music is underpinned by counterpoint. And there's all the different instruments. They might be playing different notes. They might be in different keys. But you put it together and it's harmonious. It's harmony. And that's the way I see the way the planet works. It's harmony, and we have to try to understand how all the different bits work.
And I take my hat off to you because you understand and you've dived into the chaos in certain areas of the planet and certain processes, but you step back and you look at the harmonious, the way the planet moves. And when we come and go and have our lives on the planet, we know that we are fitting into part of this universe. So I want to thank you. Is there anything else you want to talk about? Do you want to list the names of your books? Because I would love to see your books more widespread.
Well, there are 11 books. 5 or 6 of them are geological books. I was once editor with 2 others, editor of the Encyclopedia of Geology, written a book about creationism called Telling Lies for God. You mentioned A Short History of Planet Earth, Heaven and Earth, a shorter version of Heaven and Earth called How to Get Expelled from School. I took exception to a papal encyclical about climate, so I called that one Heaven and Hell. The Climate Delusion and the Great Electricity Rip-Off was a 2019 book, and the 2020 book is Green Murder. You won't hold me down.
No, thankfully for that too. Anything else you want to say or comment on?
Well, I'll just say that my computer is telling me I've got low battery, but I don't.
Great. And I want to thank you very much for your time. You've given us, almost 2.5 hours. It's been really appreciated. But I want to thank you especially for the way that you stand up for science. You have done for many decades. You're a promoter of science. You just promote the science around the world. You've done it not just in Australia. And I want to thank you for your passion and your clear intellect and your effective communication. But above all, I want to thank you for your love of science and the passion that comes through when you're discussing science. Thank you very much, Professor Ian Plimer.